All right, welcome back, calculus students. What I wanted to do today for you guys was let's start going through a little bit of what to expect in your calculus class this year. I'm not going to go over functions, graphs, those basics, and I'm not really going to go too deeply into limits. The main focus that I want to get into today is really what the derivative is. Okay. Now, I want to start off by mentioning that in calculus, a lot of students assume that it's a tougher class than everything, right? So you've got all of these math classes up to this point. You have your algebra. Let me use a different color. You have your algebra, your trigonometry, and your geometry. And then you have this thing called pre-calculus, which gets you ready for this class called calculus. But I want to point out these classes, algebra 1, 2, 3, you can imagine are your x's to the first, to the second, to the third, okay? You have to understand your functions, you have to understand the Cartesian coordinates and how we plot them out, right? What all that really is that you have a x and a y axis that you're plotting things on. And depending on your teachers, right, we may have things where, you may have done something called polar coordinates. Okay, polar coordinates are more often used in the geometry, the trigonometry side of things, where instead of it being x and y, what you have is you have a r and then a theta or an angle measure, right? So, Cartesian coordinates is your x comma y, which is what the majority of things will be talked about. But there are going to be little bits of polar coordinates in calculus, but they tend to be on the tail end of your class. So keep that in mind. The majority of things are going to be in Cartesian. All right. Let's do that. Okay, so what else do I want to point out? You've got your trig, you've got your sine, cosine, tangent, and all of those graphs. In your geometry, you should understand your area, perimeter of your geometric situation. So your circles, your squares, rectangles. You're not quite as expected to know as too much about polygons, too much about that, but you do still want to understand your triangles, and that goes back to your trigonometry for sure. Your side angle, angle, side angle, those types of situations for trigonometry, those are important to keep in mind. All right. Now, just here, we're just going to focus on the calculus part. What is calculus? Okay. Calculus is the study of how change is mathematically. Okay. So I want you to understand the first word I want you here to understand here for calculus is the word change. Okay. And the most common symbol that we'll see is this called delta, right? Delta is a triangle. And I want you to think of it as well is we learn a lot of triangles in these Cartesian coordinates. And when you do have those triangles, you can imagine that happens to be rise over run, right? Rise over run. And so up to this point, if you were to look for this, your slope, that's equal to rise over run. And you guys know that. That's very basic. And I want to point out, this is the standard or the basis of what we're looking at in calculus. We're not so worried about what value we might have now on x squared, but more so what will continue to happen if we move left and right, and our slope gives us hints about that, okay? How this triangle shape is will give us an idea of the slope. It's assuming in this situation, you can think of this as your your miles per hour. So velocity is miles per hour. And if I gave you, I told you right now you are at 100 miles away from home, and then you're driving at 60 miles per hour, right? Where are you going to be in the next hour? You'll be at 160. That's pretty easy to predict or to estimate in terms of that, okay? And in this situation, it's the same idea with our data that we're getting, is we're going to be looking at slope overall. That's the main thing, okay? We're going to go through a couple of these pages real quick just to show you that. All right, so derivatives, right? Derivatives, I want you to understand right here where they start to get really complex. This is a very common formula. Your teacher will use either A or H. Some of them use delta X. They're all the same thing. Just keep in mind it may change. Generally what this formula is that you have 2 points, okay? Let's draw this out. You've got 2 points. On these 2 points, what you're trying to do is you're trying to find out the slope, okay? So you're going and you're drawing your rise over run. Now, in most of our cases, you should understand, right, that we would use X and Y. If we don't understand these values or what they happen to be, we'd probably go ahead and say, this one is X2, Y2, right? While this one is X1, Y1, okay? You see that? So in that situation, that's very basic. You guys have learned this from algebra, from the, you met probably even as early as like 5th or 6th grade type of thing. Now you're, being in a calculus AP class, this formula just got a little bit more complex. That's all I want you to understand. It's a little bit more complex, okay? Here, what we have is technically, instead of that, we have f of x2, right? Because we're plugging in x2 into this, equation, and that's giving us this value. Then the bottom one would be f of x1, right? This one. Now, they're going to make this a little bit more complex by showing you and using that concept that we talked a little bit about, the limits of things. We're going to start to take not only just the slope anymore, okay? The slope is rise over run, and we know that rise over 1 is y2 minus y1 over x2 minus x1. That's easy, okay? You guys know that, right? The distance here and the distance here, this minus this, right? If this was a 10 and this was a 3, this would be a 7, right? Easy enough. So that's the main formula that you guys have learned since, potentially even elementary school, middle school, maybe the beginning of high school, depending on how your teachers taught it, but you've seen this equation before. It could just be f of b minus f of a over b minus a, if we were to call this a to b, right? Okay, right, this would be f of a and this would be f of b minus f of a, okay? That's rise over run. Now, what we want to understand is this is just slope. What we need to do next is we need to understand that the derivative, okay, this word that we're going to talk about, the derivative, is essentially all of calculus A, okay? Calculus A is focused on the derivative. It's a rate of change, but it's not just slope, like I said, okay? This is another way to say f of b minus f of a over b minus a, but it's f of x over f of a over x minus a. Same idea, okay? The difference for calculus and for what a derivative is we want to understand what would happen if we made this bottom number very small. So from here to the next point, we're actually thinking of this, if this was a 1 right here, right? And this is f of 1. What we want to do is we want to make this run as small as possible. We'd keep using zeros and put a 1. So it's not just, it's not that we're not moving, but we're moving and finding out exactly what that value happens to be right there, because there's still a slope that we could use, even if we make this bottom part, this run, really, really small. Okay. And with that being said, it gives us this equation that we need to put together. Let me pull that up, and that is right here. You have your value, right? And then you have this distance or movement of A. That movement of A, they're trying to make them go toward each other, right? Now, this is going to be the formula that you'll be asked of. It's pretty much what we call the fundamental theorem of calculus. This is the same idea. You can understand this as f of x as well. And what you're doing here is you're making h down here as small as possible, pretty much 0. How does this formula work? Well, same idea what we just did. You got x, and here you've got x plus h. That gives you f of x. That gives you f of x plus h above. That triangle that now exists, okay, is now f of x plus h minus the bottom one, f of x. You see that? And here, x plus h minus x, right? X plus h minus x will just cancel out your x's and leave you with the h on the bottom, because this is the distance of h. And then, so this is just a slope formula, keep in mind, without the front part here. So we got to practice writing this out, the limit as h goes to 0. So the purpose of today's class, I want to make sure that you guys practice this. Not only practice drawing that I showed you, okay? Draw this out. Label this point, label this point. But here's what I want to have you guys practice writing. The limit as h approaches 0 of f of x plus h minus f of x all over h. And I want you to be aware of this. This is how I want you guys to think of it, okay? You guys know this part. This is what we call slope. That's easy. However, what will we call this? This right here is making this 0. So making this just what I want to think of as momentary, right? Just for that moment. If I was to have you, while your parents are driving or whoever takes you around is, in the car, and you look at the miles per hour on the car, and I said, right now, what is the miles per hour, right? It might not be 60, it might be 57, right? It might not be a round number. It might, your mom might be accelerating right now. So right now, what is, because if this graph was going up, right? And we're going faster, or if it's leveling off type of thing, every point along the way, the slope will be different, okay? So momentary, I want you to keep the mind of instantaneous. The key word in here is the instant, right? Like instant noodles. It's very quick, okay? Instantaneous slope, or another word for slope is, okay? So easy question your teacher may potentially ask you in the upcoming quiz, upcoming test is, what is a derivative, right? A derivative is what we would consider instantaneous rate of change I consider that to be the full answer, at least in my classes. That was what I'm looking for. But I also will accept in the beginning of the class something like quick slope, right? Slope at the moment or momentary slope. Those are acceptable to me in the beginning. Once we get into, and the weeks go by, you're going to hear the words instantaneous rate of change so many times that should become the default of it, okay? But momentary slope isn't the bad way to explain this, to get yourself familiar with what the concept is, okay? In terms of calculus, I'm here to help, so please don't hesitate to reach out if you do have questions, all right? I'm all over Instagram. I'm going to do my best to continue to post here on YouTube so you guys get the help on this. And don't forget that this book that you guys can actually access is all online on OpenStax. So go ahead and grab that if you'd like to. All right. Hope to talk to you guys soon. Leave a comment if you've got questions or if you'd like me to help out with additional things, and let's chat from there.